Hello and welcome to yet another video of Cornerstones of Math. Today we are going to solve the following problem. Consider the n by n matrix A. The elements of the first column is all 1, the second column is all 2, and so on, and the nth column consists of n. With this matrix, calculate A squared, A times A transpose, where A transpose is the matrix obtained by switching its row and column indices, A transpose times A, because matrix operation is not commutative, hence it may differ from the previous one, and A cubed. Alright, let's do this. First, A squared. It is this multiplication. Here, instead of writing the entire matrix, let us use the index notation for the elements of A squared. That is, A squared sub ij refers to the ith row and jth column of matrix A squared. And let us recall how we do the matrix multiplication. In order to obtain the element on ith row and jth column, we take ith row vector from the first matrix, jth column vector from the second matrix, and then multiply the corresponding elements in these vectors and add them up. So for A squared, the ith row is 1, 2, 3, so on, n, and the jth column is this vector where all of its elements are j, so we have A squared sub ij is given as 1 times j plus 2 times j plus so on, plus n times j, so 1 plus 2 plus n times j, and we know that this part can be written as n plus 1 over 2, so this times j. Therefore, A squared can be written as first column is all n plus 1 over 2, the second column is all 2n plus 1 over 2, and so on. And nth column is all n squared n plus 1 over 2. Or we can take out the real number n plus 1 over 2 to the front and write 1, 1, 1, 2, 2, 2, n, and this part right here is just matrix A, so this is equal to n plus 1 over 2 times matrix A. Next, A times A transpose, which is this multiplication. Here, let us also consider in terms of its element on ith row, jth column. Here, ith row is 1, 2, 3, n, and jth column is also 1, 2, 3, n. So we have 1 times 1 plus 2 times 2 plus so on, plus n times n. So 1 squared plus 2 squared plus so on, plus n squared. And it is known that this can be also written as n plus 1, 2n plus 1 divided by 6. Which does not contain any row index I or column index j. Therefore, matrix A times A transpose is the matrix where all of its elements are n plus 1, 2n plus 1 divided by 6. So we can write n plus 1, 2n plus 1 over 6 times the matrix 1, 1, 1, 1, 1, 1, 1, 1, 1. Next, A transpose times A. Here, the ith row has elements I, and the jth column has elements j. So we have A transpose A, ij is given as I times j plus I times j plus so on plus I times j, which gives n times ij. Therefore, A transpose A is given as, the first row where I equals 1 is given as n, 2n, 3n, so on, n squared. The second row where I equals 2 is given as, now 2n, 4n, 6n, 2n squared. The third row is 3n, 6n, 9n, 3n squared, and so on. And the final nth row is, now starting from n squared, then 2n squared, 3n squared, all the way up to n times n squared, so n cubed. Here we can take out n to the front and write 1, 2, 3, n, 2, 4, 6, 2n, 3, 6, 9, 3n, and n, 2n, 3n, so on, n squared. Notice that A transpose times A is not equal to A times A transpose, indicating that matrix multiplication is not commutative. Also, it is worth pointing out that generally, the transpose of matrix AB is not equal to A transpose times B transpose. The correct property is AB transpose is equal to B transpose times A transpose. Therefore, if we apply this to A transpose right here, so if we take transpose of this matrix, this is equal to A transpose transpose times A transpose. And since A transpose transpose is just A, we have A times A transpose, which we can easily check with this result. In a similar way, the transpose of A transpose A gives A transpose A, which you can easily check with this result. Now the final one. Here, let us use the previous result that A squared is given as n plus 1 over 2 times matrix A. So A cubed is equal to A squared times A, so n plus 1 over 2a times a, so n plus 1 over 2a squared, and if we use this again, we have n plus 1 over 2 squared times a, which equals n plus 1 over 2 squared times this matrix, which you can also write like this. Also, since there's this famous property that n plus 1 over 2 squared is actually the formula for the sum of cubes of natural numbers, we can also write a cubed as 1 cubed plus 2 cubed plus so on plus n cubed times matrix A. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.